Hey guys, let's take a look at some strange looking stuff. It can be kind of intimidating, but the nice thing is as long as you're somewhat halfway right, doesn't matter if you match what the book has for an answer, as long as you're kind of close, you're okay, which is kind of a strange thing for an Algebra 2 book, but it's true. Let's look at something first. Let's go back and make sure that you can do an OLE like this one. And in other words, let's look at this line. And you need to figure out how to write the equation of this line. And that's what is going to help us to do these a little bit more experimental data, similar kind of looking graphs. But first off on these, and I encourage this for anybody who struggles with these, just go ahead and immediately write, this is the equation of a line. Y equals slope x plus the y-intercept. Boom. All right? So what you're going to do is, you need to find this and you need to find that. Now that's the y-intercept. You're going to look at this and go, I don't see where it crosses the y-intercept. I can't do that. You can in just a minute. All you need to do is first find the slope. That's this number here. Well, you can easily find this by just counting. First off, you know the slope will be positive, right? Because the line is going up into like a positive direction, we call it. There's a point here, we'll just call it right there. And you could even, there's another one right there. So your slope will be 1, 2 up and 1, 2 over. So in other words, your equation of the line starts off looking like this. Y equals 2x plus b, okay. The only thing you need to do is to find b is to find a value for x and a value for y. And those values can be anything you see that's exactly a point that crosses that point exactly somewhere. You don't want to pick somewhere like this. Here is fine, here is fine, here is fine, all the way up here is fine. Doesn't matter which one you pick. I pick one with smaller numbers or easier numbers. Now it looks like right here, this one, you have a point. You tell me what that point is. How would you describe it as an x and a y? What is that point? Okay, well, yeah, the point is 4, 0. And of course, don't forget, that's the x value, that's the y value. That's what you can stick in here and figure out what the b is. So you put your y, which is 0, in there with 2 times x, which is 4, that'll be 8. 8 plus b. Well, obviously, if 0 equals 8 plus something, that something has to be negative 8. Just solve for b. So you've got this so far. So all we need to do is just go ahead and put the b in there. So y equals 2x minus 8. And by the way, that's your y-intercept. Is that reasonable looking at this graph? In other words, if you were to keep this going down like this, would that be about negative 8? Well, yeah, 1, 2, 3, 4, 5, 6, 7. I mean, there it is. There's proof, okay? So that's how you do an equation of a line, just looking at a line, all right? Now, look at the next one here. This is close to it. It looks super complicated, okay, because we're talking about experiments, and looks like chemistry and kilograms and bronze and copper and potato salad and stuff like that, except for the potato salad. But you just treat this exactly the same way. Just you go, okay, I'm going to start and go y equals mx plus b. But let's read it first, sorry. This data comes from an experiment with bronze and copper. Write the equation of the line that gives bronze as a function of copper. Don't worry about it. Looks, oh, the functions in bronze and copper, and oh, how much is the weight of bronze? We don't care. We don't care. All we're doing is writing an approximate equation. Now, if you look at those dots, okay, this is what the experimenters got when they did these experiments with copper and bronze. We don't know what it was. I don't know. Who knows? But if you notice, there's really no way you can exactly draw a line through those dots. You know what I'm saying? I mean, a straight line doesn't go through those results that they got. These results are rough. You know, somebody else might have written it like this. I mean, somebody else could have done like that. I mean, you could have done this way or something like that and got most of them. Who knows? That's an approximate. But let's go ahead and use what they have. And you'll be writing these in your books, like maybe take a ruler and a pencil and just kind of draw an approximate line. And excuse me, you're going to get different answers from the book. I mean, it's almost impossible to get the same answer as the person, if you're both doing it, to get the same thing. You'll get stuff that's roughly similar, but if it's roughly similar to the answer of the book, go to the next one. you're good. Okay, so let's first off just do this. Now eventually this is going to change, but let's just go ahead and start off like normal. Y equals slope x plus b. Okay, we there? Same thing. Okay, and we'll change this. The y-axis is going to turn into, well, that's going to turn into the bronze, because that's the way the bronze is going up, right? And eventually the x is going to turn into the C, because the copper is this way, just like your x-axis looks like this and your y-axis looks like that. So eventually we'll turn it into that. If you ever forget to do that, you look at the back of the book and it says something about bronze and copper and you have y and x, it's fine, don't worry about it. Just substitute it, make sure you're good. If it's close, go to the next one, okay? All right, same process, okay? We're looking at this and going, okay, first, I can't see the y-intercept here, or the bronze intercept if you want to call it that. So I'm going to have to find the slope first. Well, let's just pretend this is the slope. Now, one thing you got to watch is you're not just going to be counting by ones every time on this axis and on that axis. You have to look at the axes. They will tell you how many each unit is, either this way or that way. Okay. All right. Well, we can take this as a point right here. And then we could take this as a point right there if you want. It looks like that kind of, I mean, you could really probably take this as a point as well. Since we're kind of roughing it and estimating, that's pretty close to being right there on the corner. You could use that if you wanted to. But just for the heck of it, since they drew this like this, let's go ahead and use it. All right, well, let's remember that it is the rise over the run. Okay, first off, it's going to be positive because it's going up and to the right. Okay, so the rise, in other words, we're starting here and we're going all the way up to here. All right, that's important. Okay, so that's the number that's going to be on the top. So we're going from here. You tell me, what is this number right here on the side? Okay, it's right between 0 and 10, right? Okay, so this is going to, each one of these is going to be a 5. That's why you're counting. So this is a 5. So you're going from 5 all the way up to 40. That gives you 35. All right. In the same space, in other words, you're starting here and you're going all the way over to here. Make sure you have this correct, okay? You're going from 5 all the way over to 15, which is 10, right? And usually what happens is, by the way, you'll use a calculator for this one, definitely. Okay, much easier. Let's go ahead and rewrite this as, we'll say y equals 35 divided by 10 is 3.5. 3.5x plus b, okay. Now, obviously, we're missing the b, right? Okay, we need to do that the same way as we did on the last page. After we find what the slope is, we're going to have to put in a value for x or y and figure out what the b is, okay? I think the easiest one would probably be right here, this one right there, all right? Now, if you go over, the x will be 5, okay? And then the y, if you go up, that's also 5. So you're just going to go y is 5, 3.5 times 5 plus b, okay? Well, 5 equals 3.5 times 5. This is where you want to use a calculator to save time for yourself. 17.5 plus b. And if you do the arithmetic, 5 minus 17.5 is negative 12.5. That is your b. That is what goes right here. Your equation is going to be y equals 3.5x minus 12.5. Okay. And if you want to get it exactly looking like what they have in the book, just go ahead and substitute for x, you have copper, and for y, you have bronze, and we'll just call them b and c. And then that'll be b equals 3.5c minus 12.5. Now, in the back of your book, if you check this answer, and it says, bronze equals 4c minus 15 whatever, fine, close enough, go to the next one. You're good. Okay. All right, let's try another one. This data came from an experiment with nitrogen and sulfur. Write the equation of the line which gives nitrogen as a function of sulfur. Okay, well, again, approach it the same way. Great idea to do when you don't know how to begin is just go, my basic equation of the line is y equals slope x plus the y-intercept. All right, I'm going to find out first what the slope is, okay? I'd go, goodness sakes, you can go from here all the way up to there, or no, I won't work with it. I guess really maybe from here to there, maybe from here to here, whatever, whichever one you want. All right, well, let's do it. So how far up do we go from here to here? Right, from here on this spot to there on that spot. Well, we started at 1, and it looks like all of these are 1s, right? Okay, so we go up 1, and then how far over do we go? That's the question. Well, we go from 10 to, what is this number right here? 15, right? Okay, so we go over 5. Okay, so let's go. Our slope will then be y is equal to 1 up and 5 over x plus b. Okay, we there? All right. Now we need our b. Take any point you want that's right on a point. You could take either one of these. I would take the one that's absolutely the easiest to piddle with. Looks like it's probably this one. Okay, well, this point is 10 over, and then it's 1 up, right? So in other words, our point is 10, 1. That's the x, that's the y. Let's go ahead and use this and figure it out. So y equals 1/5 x plus b. So we got a 1. That's what the y is. 1/5 of 10. I'll just put it over 1 so we can multiply the fractions, plus b. All right? So 1 is equal to 1 times 10 is 10, 5 times 1 is 5, so 10 divided by 5 is 2, plus b. And then b is going to equal 1 minus 2, or -1. Well, now we can go back in here and go, okay, we had that equation. It's going to be y equals 1/5 x plus b. Well, forget the plus b. I'm putting -1 in there, because that's what it is. There you go. And if you want, for the rest of the time, you can leave this as your, equation. You can just look in an answer book and check if yours matches and it's the right, whatever kind of elements you're working with. Let's just, for the heck of it, say, okay, let's just do this to where they have it. So we need to replace this and replace that. Well, the y goes with the nitrogen, and the sulfur goes with the x. So y is nitrogen, so we'll say N equals 1/5 of sulfur minus 1. And again, in the back of the book, if it says N equals 1/10, or, I don't know, 1500ths or 3/20ths or something like that, that's kind of close to 1/5 s, good enough. If it says, 1/8 s minus 1.2, or even 2 would be fine, or 3 even. I mean, it could be something like that. Again, you got to remember, we're not connecting these perfect lines, so, oh gosh, this is perfectly where it goes across the y-axis like it does on this one. Not going to happen. This is an approximation. This is guesstimating. So you're not going to get an exact answer. If it's close to what they have in the back of the book, next problem. Do it. Okay. And that's it. That's experimental data. All right. First off, let's do an extra parenthesis around the end of that. All right. For all you OCDers out there. All right. We're going to do simultaneous equations. We have done these tons of times before, but look at that example. What is different about that example and the two, other x and y sets of two equations that we have solved before? What's different about those two? Okay, they have fractions and decimals, right? Which gives us the name of our chapter, fractions and decimals. Okay, with simultaneous equations. All you need to do on these, and again, you can solve this with substitution once you get them, or you can do elimination, whichever one you like. We won't bother to do that now because I'm sure you know how to do that. Our job is to make this new looking set of equations look like an old set of equation. It's pretty simple, okay? Let's do the bottom one first. It's probably the easier one to do. All we need to do is make all of these coefficients integers. Okay, so we've got to look at going, well, how far do we have to multiply? In other words, how far do we have to move the decimal over to clean up the worst offender, we'll call them. Okay, and it's 2 times, right? So this needs to go over twice to get rid of that decimal totally. That gives you 6x, okay? If you do it to 1, you got to do it to all of them. Okay, so this goes over twice, and don't forget, that's not going to 2, there'll be a 0 there. That'll be minus 20y. And of course, this also has a 2. That'll give us 104. Okay. The top equation is the one that might take a little longer than the bottom one. But don't forget, the way to clean up, rational equations like this to clean up the denominator, you've got to multiply by the least common multiple. And in this case, it's 10. Okay, so this is, you're going to want to go all the way across and multiply by 10. You can call it over 1 if you want to. Now let's do this part first, okay? If you multiply by 10 and you divide by 2, you're actually multiplying by 5, right? So 5 times x will be 5x. Done. This one is positive 3y over 5. And don't forget, if you are multiplying by 10 and dividing by 5, you're actually multiplying by 2. So 2 times 3y is 6y. Last one is, again, that's going to be 2. So this, don't forget that there's a negative there. So what you've actually got is 10 over 5 is 2. So negative 2 times 2 is negative 4. And you know how to solve those. We won't bother to set it up with either a elimination or substitution. You can handle that. I would probably suggest elimination by multiplying the top by 5 and the bottom by 6. You could even, if you wanted to, divide the top equation by 2, since 6, 20, and 104 are all divisible by 2, just to clean it up and make it easier for yourself. But whichever way you like to do is fine. Okay. All right, let's go. We're going to do one more thing for this chapter, and we're going to change rectangular form to polar form. And let's review first, and we're going to go, and again, this is what it usually looks like in your book, this kind of thing. Change 6 and then 120 degrees to rectangular coordinates, okay? You're going to need your calculator for this one and use some trig functions. So you want to copy this down, go ahead and pause it real quick. And you don't need a piece of graph paper. You can just draw an approximate. It doesn't need to be even close to looking right, as long as you can visualize it and get the right angle. Okay. All right, well, let's take a look at this first. Okay, we're going to go 120 degrees first. Well, we know if we start from here, we go over 90 like this, and we're going to have to go over how much more to go to 120 degrees? 30 degrees, right? Okay, so in other words, we're going to draw our little triangle, okay? It's going to be a length of 6, right? Because that's a 6. Here's our little makeshift triangle. This is a 30-degree angle right here, but that's not what we want to focus on. We want to focus on this angle here, which we know is 90 minus that 30, which will be 60 degrees. Okay, and there we go. And we'll call this x, and we'll call it y. All right? So rectangular coordinates is what we want. Okay, so we are going to have to figure out x, and we're going to figure out y. All right, so let's look at the 60-degree angle. And if you wanted to, you could go up here and you know this is going to be a 30-degree angle, because 90 plus 60 is 150. Boom, there's 30 degrees left. But let's just work on the 60-degree angle. Okay, let's find this. And if you're looking at this angle, what is x? What is that side called? Is it adjacent? Is it hypotenuse? Is it opposite? What is it? To the 60-degree angle, this is adjacent, right? Okay, so we have adjacent over hypotenuse. What is adjacent over hypotenuse called? Okay, that's cosine, right? So we need to set up an equation. We have the cosine of 60 degrees equals x over 6, okay? All right, so let's find out, using our calculator, what the cosine of 60 degrees is. All right, so 60, and we're going to go, we need trigonometry here, don't we? All right, cosine, boom, 0.5. Look at there, okay. So this is going to be 0.5 equals x over 6, okay. And again, we can set this up as an equation and then just cross multiply. So x will be 0.5 times 6, which I'm sure you guys all know is 3. So that gives us the length of this side. That'll be 3. That's our side length, okay? Now again, you can either use Pythagorean theorem, like 3 squared plus something squared gives you 6 squared, or you can just go ahead and go, well, I want to do 60 degrees. It's going to be the opposite over the hypotenuse. Opposite over hypotenuse is called sine, right? Okay, so let's kind of break this off a little bit. We got the sine of 60 degrees equals y over 6, okay? All right, so let's go back to our 60 degrees, and we got our little sine, and that'll be that, okay, 0.866, all right? So we've got 0.866 equals y over 6, and again, you know, you'll get faster at doing this. So 1 times y is y, of course. Then 0.866 times 6, let's just leave it in the calculator and go, well, times 6 gives you, boom, oops, I shouldn't have done that. Okay, 6 times, okay, let me just try that, make sure I got that right. 0.866 times, okay, let me clear this all out. 0.866 times, okay, obviously this is not all cleared out. Okay. All right, let me get that back on here. Okay, let's go over to trig here. Don't need that yet. Okay, here we go. 0.866 times 6 equals 5.1, we'll just call it 5.2. Okay, so y is 5.2, all right? And that'll be 5.2. And don't forget, the way you're going to write this to rectangular coordinates, you're not, this is the x and this is the y. But remember, you're going to the left on this x value. So what you're going to have to write is -3 and then 5.2. The 5.2 is positive because the y is going up in value. So there you go. That's changing a, polar to rectangular and so on. Okay. All right, let's take a look at this. This is a little different, but a lot the same. We're going to change rectangular form to polar form. In other words, we're going to go backwards. Okay. And if you look at this, this has an r and a u instead of an x and a y, but again, it's the same thing. R and u is x and y. They are x and y. It's alphabetical order. If you ever forget, r corresponds with x, u corresponds with y. So to do this, go ahead and draw this. And of course, again, you don't need a perfect drawing. Absolutely not. Just draw an approximate. Make sure it's in the right quadrant first, okay? So I'm going to go, okay, so this, in other words, this 5 corresponds to the x value. In other words, this is like doing, the point is -5, and then this is the y value, so this will be like -3. In other words, that's, you can, if somebody said to you, draw a point, this point -5, -3, you'd go, okay, no problem. 1, 2, 3, 4, 5, that's the x, and then you go 1, 2, 3. There it is, right there. Okay, then you go like this. Oh, gee whiz, what a horrible. All right, I can't let that slide. That's just awful. There we go. Okay. And there. Okay. The sun got in my eyes. I couldn't draw it straight. All right, there's our line, okay? And of course, you can just go and make yourself a nice triangle out of that, okay? Now the question is going to be, okay, and don't forget, if you're, here, you're trying to figure out where your buddy is lost in the ocean, and he tells you, whatever, -5 miles west, or 5 miles west, and then 3 miles south, you got him. You send the helicopters, and you take, you pick him up, at least what's left of him after the sharks have been at him, okay? But he says, I don't know, I went on a straight line, somehow way out here, and you've got to go, well, first off, well, how far out did you go? How many miles? And then the second question is, at what degree did you go out? What angle did you go out? Okay, I need to know that. I can't find you, okay? So that's what you're going to try to find out. You are here. How do people get to you? All right? So in this one, you're going to have to figure out what the angle is all the way to there. All right? Because don't forget, we always start right there and go counterclockwise and find out what it is. The second thing is, you're going to have to find out how long this line is. Because you want your buddy to be able to go, okay, I'm going to go to this degree angle and this far. Because you don't want him to stop right here and give up. You got to go all the way. Okay. All right, so how do we do this? Well, this is our right angle. We can call this, our R. We can call this our U. If you want to call them X or Y, whatever, don't worry about it. And if in the back of the book you write somehow something X and Y for R and U, just go, oh yeah, that's supposed to be R and U, no big deal. Okay, well, we need to know what's going on here, okay? Well, we've got it. We know what this is. We don't have to write R and U. We can write the actual numbers here. That's going to help us a heck of a lot to figure out what this is. All right, here we go. So this is going to be 5, and that's going to be 3, okay? What I would do if I were you is go, well, I can easily find this, which is the hypotenuse, by simply using the Pythagorean theorem, right? I mean, you can just go, okay, the hypotenuse is going to be a squared, which will be 3 squared plus 5 squared. That'll be, we'll call it the hypotenuse squared. All right. That's 9. That's 25. And that's going to be h squared. So h squared will be 34. Your job is to go, okay, what's the square root of 34? Okay, well, let's find out. All right, 34 square root, doink, 5.83 we'll call it, okay? So in other words, you tell your buddy, hey, I'm 5.83 miles, my boat, odometer reads that. So your buddy goes, okay, I got it, I got 5.83 miles, okay? Obviously, then your buddy's next question is, which angle are you at? Which way do I go, okay? Well, you got to figure out where to tell him to go, okay? Well, let's do this. You can actually, using an angle, let's just pretend this is the angle you want to find, and that is what you want to find. You want to find this one, all right? So you're going to actually use, the inverse of cosine, sine, tangent, all that kind of jazz to get him to get the info to him, okay? So let's go next and say, all right, well, okay, let's look at this angle, okay? And you go, well, the tangent, let's see, I've got, well, you know what, you could, if you want to, put 5.83 here as well and use that if you want, it doesn't matter. But let's pretend you didn't have that. You can go, I'm looking at this angle, I got the opposite and I got the adjacent. Opposite over adjacent. Well, opposite over adjacent, what's that called? Tangent, right? Okay, so in other words, you've got the tangent of some angle, that who knows how many degrees, is opposite, which is 3 over 5. Now, if you do in your calculator 3 over 5, that gives you 0.6, okay? So you're looking for an angle that'll give you an opposite over adjacent of 0.6, okay? And that's where you go back to your calculator and you go, okay? 0.6, and then you're gonna go, okay, we're gonna go second, and then we're going to go tangent, okay? So, in other words, you've gone backwards. You're not trying to find out what the tangent of is and getting a number. You're saying, I've got what the tangent is. I need to find out what kind of angle gives me that. So you plug in 0.6 in your calculator, and you do inverse. If you notice, that second is up, and it's well, trigonometry, excuse me. The second, and boom, you can see that, like something like a -1 is an exponent. That's what you'll see. That's a universal sign of that. Which tells you the angle that gives you that is 31 degrees. We'll just call it 31 degrees, okay? In other words, this angle right there is 31 degrees, okay? Now you can tell your friend, okay, you go 90 degrees, you go 180 degrees, and you add 31 degrees to that, right? Okay, so 31 degrees added to 180 is 211. So you're going to go tell them 5.83, and then it's going to be 211 degrees. And there you go, and that's your answer. Okay, and that's how you change rectangular form to polar form. Okay, well, let's try practice problems, and go ahead and pause it and try A. Okay, well, again, the way you want to start is to start with your basic equation, y equals mx plus b, slope x plus y-intercept, okay? You want to find the slope. Pick any two. That looks pretty good right here. I don't know, that looks pretty good right there. Let's try those two, all right? So in other words, we need to figure out how far up do we go from here to there. Well, here, what is that number right there? What are you starting at right there in that dot? You're starting at 50, right? Right between 0 and 100. So we're starting at 50. We're going all the way up to 200. That means you're going 150 up, right? So you have y equals 150 over something x plus b, all right? In that same, up move, you're going to start here and you're going to end up here. Well, how far do you go from here to here? You can read that. It goes from 30 to 32, right? So it's going to be a 2. So if you want to, go 150 divided by 2, that's 75. 75x plus b, okay? In other words, now you need where that y-intercept is going to be, somewhere down here, right? If you kept it going somewhere down here. Again, it's not exact because we're guessing at a line here. So if yours isn't exactly right, Don't worry about it. Go to the next problem. Okay, well, let's figure it out. Let's put a point here. That looks like the easiest point right here. If you go across, that's going to be 30 for x and 50 for y, right? Okay, so you're going to go 30 for x and 50 for y. There's your 50. 75 times 30, all right, plus b. Criminy, that's a big number. Okay, all right, so 75 times 30, you can use a calculator, is 2250 plus b, and that equals 50. All right, we can go down here on this one and subtract that. We're going to get the equation that says b is equal to 50 minus 2250, which is negative 2200. All right, so there you go. There's our b. We have an equation here. Y equals 75x minus 2200. And of course, if you want to go ahead and do the nitrogen and the fluorine and so on, that's good. No big deal. We know nitrogen is going to be our y, so we'll call it an N. And then 75, and then this will be what? Fluorine, F minus 2200. Now, if yours is 100F minus 1000, or if yours is 82.6F minus 700, or 1500, or 2000, fine. Go to the next problem. Good enough. All right. All right, pause it and try B. Okay, on this one, B, we're going to need to take care of this by multiplying by 10 over 1. That gives us a new equation. All right, let's go this first. If you're multiplying by 10 and dividing by 2, you're actually multiplying x by 5, which gives you 5x. You will not be surprised to learn. Okay, this one, if you are multiplying by 10 and dividing by 5, you're actually multiplying by 2 times 3y is 6y. Wait a second. Why does this look very familiar? Is that the same one we just did? It is. I'm just going to go ahead and solve this one as an example for you then. All right. And again, if you're multiplying by 10 and dividing by 5, you're actually multiplying by 2 times negative 2 will give you negative 4. Okay. And this one, of course, we know what to do. We move everything over twice. That gives us 6x. That gives us 20y. And that gives us 104. All right. Well, let's go ahead and multiply. Let's do this. This is easier. I'm going to take this and divide everything by 2 to kind of clean it up. You know what? I won't do that. I'm just going to go ahead and pretend like I don't have that knowledge of how to do that. So we'll just multiply the top and the bottom by something. I'll go ahead and do this by 6, since that'll give us the same number of x's, and this by 5. Okay? So we have 2 new equations. 6 times 5x, 30x. 6 times 6y, 36y. 6 times negative 4, negative 24. All right. 5 times 6x, 30x. 5 times 20y, 100y. Good grief. Okay. 5 times 104 is 520. Good gravy. Okay. Okie doke. Well, let's subtract. We got to subtract those 2. That goes away. 36 minus 100. Holy Moses. Is negative 64. Let's see here. I must have done something. Oh, that's what I did wrong. My bad. Okay, a quick mistake. Let me fix this really quickly. And that should have been a minus right there. Okay, I knew something was wrong. All right, here we go. That's going to be a minus. Okay, so 36 minus negative 100 is the same thing as 36 plus 100. So that's 136y. Negative 24 minus 520 is negative 544. Now, 90% of people, or almost half, will know that 136y is divisible into negative 544. Well, forget the negative. How many times do you think 136 will go into 544? Okay, if you're not sure, you can just try it. Okay, and it ends up being 4. Okay, so y is going to be 4. Of course, there's a negative, so we'll call it negative 4. That's our negative. That's negative 4 is y. Okay. Original equation, we can use either one of these if you want. Let's just, what the heck, we'll just use this one. All right. Let's bring this down here. We'll call it 5x plus 6y. Well, 6 times negative 4 is negative 24. That equals negative 4. All right, and 5x, if we move the negative 24 over, it becomes positive. So 24 minus 4 is 20, and then x equals a positive 4. There we go. Okay. Okay, pause it and try your polar form problem. Okie doke. First off, let's draw this thing. Okay, negative 3r minus 5u. So it's going to be negative 3, 1, 2, 3, right? And then negative 5. 1, 2, 3, 4, 5. Boom. Okay. And then we draw our little line. And then we draw our pretend triangle here, I guess our right triangle. And then we got to figure out, you know, what's this and what's this. Well, we know this is a 3. We know this is a 5. Now, I don't know if you remember the one we did a few minutes ago, where we kind of already figured out what this would be. That's going to be 9 plus 25, which is 34. The square root of 34 we found was 5.83. All right. We're not going to actually need that except for just the final answer, but we'll just stick it there right now. Okay. Well, the question is, what kind of angle is this? Because we're going to have to find out. You're going to need to tell your friend, I'm 5.83 miles out. And he goes, okay, what direction? You're going to go, I don't know. Well, I can't go. You're going to die of hunger or thirst by the time you know, if you don't tell me the direction. I'll look everywhere I can. Maybe I can go in a circle. Who knows? Anyway. Okay, so this, you know, is 90 degrees. This is 90 more degrees. We got to know what angle that is to add to it, to figure it out. And again, we're going to have to figure out what angle is this that gives us, and we can go ahead and we know we're going to use the opposite over here and adjacent is over there, okay? And of course, that opposite over adjacent is called tangent, right? Okay, so the opposite is 5, adjacent is 3. So what we're going to do is we're going to go, well, the tangent of, you know, we don't know the degree, is equal to 5 over 3. We good? Okay, tangent is opposite over adjacent. So we need to figure out what this is, okay? Well, 5 over 3, we can put this in our calculator. The tangent of some angle is equal to 1.6666. You just keep going and going and going. Okay. So here's what we're going to do. We're going to go 1.666666 like that. Okay. Then we're going to go. We're in trig function here, and we're already there, so we're good shape. And we're going to go tangent. Blink. And that's going to tell us what angle gives us that ratio. In other words, this angle here, according to what we put in our calculator, is 59 degrees. Just call it 59 degrees for heaven's sakes. 59 degrees, okay? Now you need to tell your friend, okay, you're here, you've got to turn 90 degrees, 180 degrees, and then we're going to have to turn 59 more degrees, right? So that's going to be 239 degrees. So in polar form, you're going to tell your friend 5.83, I don't know, we'll call them miles, and then 239 degrees, and there you go. Okay, that's it. All right, have a good day with your stuff, and see you next time.